So now what, I think Jim is the one who proposed talking about the sun, so maybe it would be good for Jim to give us a little summary of his views.
I wouldn't even know where to start, though, with that.
Well, good. Yeah, there's a couple.
Give it a try.
Well, some of the ideas that are right, for sure, are that we have to accept is that stars like our sun can go back and forth from red or blue, and it's not a function of aging. So we should get that knocked out of the way. And I think Don Scott made that point better in his book. And he actually went into a little more of the history of Sirius. We were talking about that, how it was recorded as a red star in the past. And he actually does a better job of tracking when in history it started being recorded as a blue star. That's on page 162 of his book, The Electric Sky.
Welcome to the August 21st edition of The Electric View. I'm Neil Thompson. Today we have Jim, Dave, Heather, Richard, Edwin, and Robert. We will be talking with Jim Weninger about the nature of the sun, the histories and philosophies that built our interpretation, and what is going on inside the bodies of our solar system. Please like and subscribe below.
One thing that you saw that website on the solid surface of the sun, that's something to keep in mind too, is that even according to mainstream observations, we have differential rotation at the sun's surface, but it seems to pretty fast go down to, just from the seismic studies, it seems to go down to solid body rotation at some depth, fairly. Not all that deep below the surface.
I didn't see that one. What's that link? Or what could I Google for to find it?
Yeah, I've got it up on if you go to the current meetup.
I think it's called The Sun Has a Surface, actually, or the Iron Sun Theory, or something like that. .com or whatever.
That's right. His notes are right here.
To reference what you were saying, Jim, in Don Scott's model, just so that we all understand what we're talking about exactly, is he was referring to changing the Walter Hertzsprung diagram, I think it's called, and saying, okay, instead of it having to do with luminosity versus size, it had to do with surface current versus size. And if you put those in a graph, they are the Walter Hertzsprung diagram or Hertzsprung-Russell, I guess it is. I'm not sure. And it is the mark of the luminosity of a body based on how much current's going through it. And he said, obviously, if you change that, you will change the aspect of the star itself. So.
Right, I think I remember reading that.
I'm going to look it up now. Hertzsprung-Russell, pretty sure. But go on.
But of course, if you have a star that's that has its own constant size and it changes color, no doubt, then that reflects a change in the amount of current, which is so it's a fluctuation in the current,
and which would imply the ability to change, like the color of a star right straight up, and that and it doesn't require. It could also explain that sort of jut off to the side. Why are there red supergiants over here? And then we're starting to see that they might be in glow mode, and I think that was something to do with Betelgeuse, I believe. Jim, isn't that the one that's shrinking?
Yeah, well, all stars seem to, red giant stars for sure. They have these radial velocity pulsations, and that can be explained by changes in the electric environment. Basically, like the idea, I forget if that was Wall or Don. I know they were both on that same page, as saying that the diameter of a star might have to do with if it's sweeping up electrons and they're in a more electric electrically deficient environment, then the star is going to swell up in order to intercept more electrons, the surface of the star. That's kind of a general idea on that. I'm not going to do that one justice, though, in that.
Well, at least now we have a basis to understand generally what we're talking about. But
the traditional is the Doppler, right? They've been using that for quite a long time, and now, do we mix those two, or is it not Doppler at all?
I think it probably has more to do with what is that? The lines that move depend on and widen depending on the electric current that they're in. I'm not sure that effect. It's
that would be a different process.
Zeeman effect or something, maybe. I think it is.
The color of the stars is particularly interesting because the questions that I have is the color of a star related to the size of the body, or is it related to the power of the current within the electric universe, if you will, the activity, the amount of activity, or is it maybe related to its development stage, its age, if you will?
Well, what Neil just said about Don's what Don said in his book is that it's really kind of the ratio of the size of the surface area of the star versus the amount of current coming in.
Yes,
it's sort of that ratio, and using that model, he was able to reproduce what's been observed and given names by regular astronomers. But it has nothing whatever to do with age. I mean,
okay. No, but I'm talking about
the star doesn't wear out. It's like a piece of iron sitting there with an electric current going through it, having a discharge event.
Well,
so,
because
then
it has a periodic nature to it, though, right?
Well,
yeah, but that's a variation in the current, not an aging process in the body of the star.
Mm-hmm.
Again, going with the EU model. No, go ahead. Sorry.
No, I'm not trying to dispute that so much. What I'm trying to another question that comes up is the size of the body that's related to the power amount of current. That's what I hear you say, right?
No. They're independent variables. They're totally independent variables, and but then the ratio of those two variables is going to tell you what it's going to appear, like a red giant or white dwarf or whatever.
Okay. So two factors are involved there, and the ratio of the two determines the color, if you will.
Yeah, I mean, I say ratio, but I don't know that it's linear. I mean, it might be logarithmic or who knows what.
Well, where does that leave us with star fusion processes?
Well, there isn't any, except in the electrical discharge double layers. It's the same as what they're experiencing with the Sapphire project. That the intense energy and electric fields that get created by double layers can actually bring about fusion, and so it happens in the corona, not inside the star.
Well, I would agree with that, but still leaves the question: what is the sun? What is a star? Is it a metallic object? How did it become a metallic object? Right? That would be age as well, and we see different. We can jump to the spectral lines there, so meaning the color of the star still. There was a recent article from the top of my mind where they measured titanium, I believe, in a certain star. So metals are created there somehow.
Well, what happens is in a Z-pinch, when a Z-pinch is collecting the heaviest elements to the center. And so it ends up, when you create a star by that process, it's going to be created by the heaviest elements that happen to be around in the vicinity of the Z-pinch.
But that's the question where the heavy elements come from. I mean, what I'm trying to imply here is that, in my mind at least, the stars are the initially at least, the breeding chambers of the first elements, the first light elements, and probably some halfway the periodic table as well. And I'm not trying to dispute the Z-pins effect here, but once you have a star formed, if you will, then it becomes that breeding chamber, if you will, in my mind at least. So I'm trying to figure out how that works and how it comes to be, because I'll put it quite simply. I have no idea when people say the sun what to think. Is it a solid body or not? Is it gaseous or not? Is it driven by electric current or not? Well, I think it is, but right? But how does it? There are so many questions. I have no understanding of the sun. If I'm honest, that's what I'm getting at.
Well, you really had. There was 2 points you had there. One of them getting almost philosophical is sort of like, how did the first metal come about? If a star is metal, then how did you get the first star? You know, so that it's kind of a question like the kind of question the Big Bang tries to answer. The nearest I could come to that point is the Big Bang sort of makes everything that theory sort of gives us a timeline of a universe that's only been around a few billion years or something. But in the electric model, you could sort of think of it as a steady state thing that's been here forever.
Well, I would agree with that.
And so we know fusion is taking place now, you know, at least in the corona, but in huge galactic discharge events, you might get a whole lot of heavy metals created sort of in one episode. But then your other point was about the sun we have right now up in the sky. What is it made of? And I mean, I don't think I've seen anything definitive on it. I'm assuming it's mostly an iron ball. Cooler in the center, and probably solid.
What's the method of measuring it? That gets into that question again. So it's spectral analysis, right? So well, this is also a little pinhole to look at. Okay, and then definitively, declaratively say this is the material.
Absolutely,
it's quite assumptive.
But then it's like, what spectral line are you measuring, and where? You know, like the spectral line out in the corona, and the spectral line right in the chromosphere, or the photosphere, and then what if the photosphere is one of many double layers leading down to the actual surface?
Right.
So another tool you have is the size of the sun versus its mass. And, you know, is it as heavy as water? Is it as heavy as iron? Is it, you know?
I mean, you get into the world of uncertainty pretty quickly because, you know, and then down philosophically yet again, it's like, what's to ask Rupert Sheldrake, what is the definition of mass, you know, in this case? You know, and then you start readdressing all the fundamentals.
Yeah. And also that's why I was really interested in the sun has a surface thing. I realized because if somebody actually has a reason to believe they know where the real surface is, once you get past all the ionospheres and double layers, then you at least know the volume of the real sun. You know, which helps in calculations.
Yeah. Now, just to throw in a question there, but just a question. Do you need a solid body to create the double layers around it?
I don't know. I mean,
if not, it would be a plasmoid directly, in my opinion. And sometimes I think that certain amounts of electricity are at such an nth degree of magnitude that a solid body cannot exist within it. For example, perhaps maybe like a black hole, or other.
Or what?
Okay, but
I mean, when we look at the sun, the center of the galaxy, that's what I meant.
When we look at the sun, black holes.
Well, I know, but
let's not go to
black. That's one of my
I know.
In my soul,
heresy.
So great! I've been chased off my own show by the priests of science. Oh my god! The electric universe is coming after me. Anyway, go on there, Edwin. Sorry.
Yeah, I have a question for you, Neil. I'd like to pick your brain. You know that. Now, if we look at the sun with your knowledge, right, from an EE's perspective, an EU perspective, If we look at the sun, could it be a plasmoid, as you just pointed out, or must it be a solid body, if you will?
I think that the evidence for a solid body is obvious. It just only because of the by examining the fact that we've seen ripples run across it, and I don't mean it's. I mean it's a liquid at the top at least. I don't know if it's solid underneath, and I assume that it is. But it probably has like oceans of molten rock.
You know what they say about assume.
Yep, I know, but I've seen
just a question.
That the very first episode I watched, and I talked to Robitaille a few times, but in his very first Sky Scholar video, he talked about this exact thing, and one of the things before he gets off into his liquid hydrogen ideas, he's specifically talking about the fact that they've seen material fall down from a prominence, like been pulled back down to the surface of the sun by a prominence collapsing or whatever. Just like we've seen with Jacob's Berkeley currents there in his little jar. But when they collapse, there is a lot of energy that is released, and it as it falls into this apparent ocean, you can see concentric rings and ripples run out from that point, indicating that it is water. And some of these ripples we're talking about are as big as the planet Earth. You know, like that wave the size of the planet, you know, like just rolling across it. So that alone belies a physical surface of some sort. I can't deny that.
Do we have anything in our technology toolbox, anything that we can use to basically show evidence or give evidence that the sun is a solid body, like radio waves or radar or microwave, whatever, that we could use to basically see that it has a solid surface or not? Well, or is that already acknowledged?
There's a couple of things I could say about that. First is that as far as a plasmoid goes, if you look at a plasmoid, it's a current continuing in the same direction. I mean, it comes in one side and out the other. And the way they usually describe that is that ions are going out one end and electrons are going out the other, which is to say that the current is going in the same direction on both sides. Whereas on the sun and the earth, you have currents coming in at both poles. So those currents are going in opposite directions. And that is the sign that basically they're being attracted to something that's permanently negative. So, I mean, the sun is permanently negative just like the earth is. And that, I mean, I think that fits with Baudin's gravity model, but in any case, and then what you have is we have an ionosphere, which is, 250,000 volts more positive. So to people out to other planets, they look at the Earth and they if they were measuring its electric field, they'd say it's 250,000 volts positive to what the Earth really is. And so similarly, the sun appears to be an anode because that's what the upper layers of the sun are. They're positively charged, but the actual body of the sun is negative. Otherwise, you wouldn't have currents coming toward it from both directions.
There's something to be said for that. I think that when we see, like, for example, this picture here, this is what we sometimes think is the top of the sun, but this is just the top of the anode tufting on top of the sun. It's not really the surface of the sun. And to see through it, as Edwin talked about, is difficult because of the fact that we would normally just bounce radio waves off it or acoustically sound our distance to it. Well, there's no sound really in space to do that with, so that's out. And radar reflects any plasma almost like it was a solid piece of metal, which is one of the arguments made for people who are saying, well, UFOs, can be seen, therefore, maybe they're plasmoids, and we see the same thing with the top of Venus. The mountains on Venus are said to be tipped with metal, but other people are saying, like in the electric universe, probably not. They probably have a corona glow around the top of them, and that coronal glow reflects radar just like it was metal. So that's what we're seeing.
So basically, whatever we do, we would see, or observe a solid surface, if you will.
And of course, our electromagnetism is our only way of really doing that, and it is in a highly active electromagnetic body that reflects those waves and changes them, as we have seen. We were just, a few video slides ago, you could see how the lines were widening, and and the Zeeman effect was kicking in, and that type of thing. So,
well, and then one thing you always keep in mind is that if we believe in the whole Z-pinch star creation process, and again, like I said earlier, that gathers the heaviest elements around down to the center, and that's what becomes the body of the star or the planet. So that would argue for stars being heavy objects.
Well, if that is true, right? That would put well, then you just found the missing dark matter. All the stars put together being a big ball of iron instead of hydrogen gas makes a little bit of a difference there.
Yeah. And that's so funny to talk about an accretion disk. I mean, what does gas do if it starts to heat up? It expands. There's no way a gas is going to collect to become a star. It's ridiculous.
Now, on the other side of the coin, should we not see more iron in our spectroscopy?
Well, again, it's what do you make? I mean, what is our spectrograph seeing?
Well, mainly
seeing the radiation. How could it? I'm just putting this out as a general objection. I haven't studied these spectra. I'm just saying that if the surface is covered by all kinds of layers and the photosphere is only one of the top ones, then how do we get a spectrograph of what's inside?
Now that's a very good point.
Can't even do it to the Earth.
A shield, yeah.
Although we have noticed, just like we have noticed with sending that wonderful probe Juno, which I think actually this whole thing that we're doing now with we just launched one towards the sun, I think it's very much similar to that mission, if I'm not mistaken. It's a Juno mission to the sun. But we've noticed just from Juno the amount of stuff that we have learned by studying the electromagnetic field. And, of course, turning those instruments now towards our own Earth, we've noticed that the Earth has layers, somehow like a moving charge is moving in one direction around the planet, inside the planet. Like, we didn't know that was going on just a little while ago. Like, this is all, and obviously, this should be happening in the electric universe model, so to speak, because we're seeing that whatever's happening in the atmosphere should be happening underneath the Earth, because there is a mirror to that surface. And, just like we're seeing this prominence go up here on the sun, there should be, and I think that we're seeing it go into the tufts, and I bet you dollars to donuts, that's quite a thick layer. Like, I think, if I'm not mistaken, there's 2,000 kilometers or more is the thickness of the atmosphere of the sun, they think. That just towards the darkness below that they see where it ends with the sunspots. So, this thing is sort of reaching down. We're just seeing the top of the atmosphere of the sun. These prominences are reaching down much further in there than we think.
Mm-hmm.
But again,
so you're saying the photosphere is something like 2,000 miles thick? Is that what you're saying? Yeah, that'd be about. Seems sensible.
The Earth has the sun has a thick atmosphere, basically, and it's on fire. And what's underneath that?
Another argument for there being a metallic sun is the magnetic field, because you have the magnetic field of the two currents coming in, and they're obviously going to be fairly strong magnetic fields. But what happens then is that the sun, being metallic, really takes the vector sum of the two currents, and so whichever one is greater is going to be what aligns the metallic substance of the sun, and then we get a much stronger magnetic field out of that solenoid that then dominates those two incoming fields. And that's something you would expect from a metallic solenoid in a coil, is that the strength of the magnetic field goes way up once you put the metallic solenoid in.
Oh, yes. That's one of the things when Edwin said, when we would talk about things, the property of iron to do that to magnetism blows my mind. Like
Yeah.
it is almost. I mean, now we can make permanent magnets incredibly strong and use different materials, but just a coil and some soft iron, just like a bunch of old coat hangers put together. That is one heck of a magnetic concentration right there. The lines just go boom, right in.
Yeah, exactly.
This is one of the reasons why
And there are no lines, but I said lines. See how easy it is.
You're locked into the model.
Yep.
Now let Ido continue.
No, that's great. But, I just was going to interject. This is one of the reasons why I also think that stars are basically kind of like planets, or Jupiter-likes, if you will, meaning they probably have a solid core, an Earth-like object, or something to that effect, with a metallic core, and maybe a very, very, very thick hydrogen, whatever, atmosphere around it. If it's big enough and there's enough current, you get something, or Z-pinch, you get something like a star. So in that sense, I don't see much difference. The only thing I would like to put in is the creation of the elements. And yeah, that's a creational story maybe, but it's an ongoing thing.
You're definitely onto something there. In fact, the only disagreement I would have with you on your conceptualization is that the core part is not required. And I only mean that in the sense that besides, obviously concretions are sometimes hollow and that weird evidence there. But what I meant was,
core,
go ahead.
I meant the core of a star as in having something like a solid body object like an Earth-like thing.
Yes, that I totally agree with. But with a star and the Earth, both of them, if we see the activity of the atmosphere, so to speak, and then we see the activity of these prominences above in the corona here, there should be a place in the middle that's mostly positive, we'll call it, because the surface is negative. It's mostly positive. And in this area, there would be little activity because it's not necessary immediately right around that. But of course, there could be a spinning plasmoid in something, but because of the twisting and magnetic fields and so forth. But the activity that I'm thinking about with your model would happen between the surface and that positive point, because that is basically an layer of dielectric between a positive and negative, but even more powerful than the ionosphere, or more powerful than the corona of the sun, because it's happening even more concentrated inside. And with that in mind, I can envision underground lightning bolts of great magnitude, so to speak, currents changing material all through that planet or body.
Right.
But that's all I meant by conceptualization. But you're generally right in that sense. I wasn't trying to be picky, but I guess I am.
Now currents inside the Earth, telluric currents or whatever, that becomes a heat transfer mechanism from the Birkeland current coming into the Earth. That would produce a heating effect on the Earth,
or cooling.
Well, if you're making things move, then it causes friction and you get heat.
Well, if you Andy Hall points out that in a thunderstorm, part of this electric system of the Earth, is basically in a thermal pile. So used in series stacked little thermocouples. You can transfer heat with that, but one side cools and one side heats, depending on what you do with your circuitry. So
Well,
you can transport heat. That's what I mean.
Well, a hurricane, is a cooling thing. It's funneling tremendous amount of heat up into the ionosphere and cooling the Earth. I mean, that's what a hurricane is a cooling mechanism for the ocean.
Right.
I agree. I was specifically talking about underground telluric currents. I would see that as being a heating mechanism.
Sure.
Generally speaking, I think I would go with that. There is, especially in the way that, as we've seen from electric forces going through, in Andy's video, actually, there was I think Dive Flyfish was showing how you will get through granite a connection, and that connection will stay there for a long period of time. And I think one of the, and of course it will heat up and make that whole conduit plasma. And once it's plasma, it is the most efficient way of transferring electric current from one point to the other compared to going through the rock itself. So it's going to go right through it. And
you're saying a plasma gets created inside the rock?
Oh God, yes. If there is a current, like for example, the amount of energy between that is just leaking through from the capacitor that is the ionosphere to the ground, just roughly doing the math, is about 400 megawatts. That doesn't seem like much, but the more you concentrate that on the Earth, inside the Earth, there should be equivalent to that heading down towards the more positive area in the core of the Earth. Now, if we put that together, it's not going to do it evenly across the surface, just like it doesn't do it evenly across the surface of the Earth. It grounds out at thunderstorm points. It grounds out at tornado points. Well, the same thing would be happening under the ground. It would find lines where it could take the surface material and go towards a particular point. This is why I think that there is an active volcano in Hawaii, for example, because it's all that area around it is basically going right across it and now going into the Earth. It's finding the best way to go. It goes right through that wonderful liquid plasma it's got called lava, and it goes bloop, 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 bloop. And that's the best way to travel. And we've noticed, especially these events recently, how supernaturally fast some of this lava is traveling and how it's twisting as it goes. I mean, we've never seen that kind of stuff before. It's almost like we're looking at this right now, the prominences of the sun. It's like, it's been quite a ride in the last, 6 months this has been going on in Hawaii. So.
Well, then there's that guy who has given a talk a couple times about his theories of all kinds of structures, electrical structures under the Earth, leading to volcanoes. And
oh yes, Bruce was talking about that too, where you can see how like there seems to be a big like Yellowstone is on one thing national park there, and it seems to be is this like a part of a circuit? Is this where it's coming out at, or is it all the energy is coming across and going across the oceans and then hitting the west coast, and then we have all those volcanoes along the west coast? Is there a reason for that beyond, just typical? Because we notice that happens all around the Pacific Rim, but why? I mean, in the Atlantic, not so much. There's only a few volcanoes comparatively, but it's also not nearly as big an ocean, not nearly as big a surface area. Maybe it can process that with less, process those electrons with less surface area because of the size of the ocean is less surface area. It's
well. Someone recently in one of our conversations was talking about reasons for the volcanoes being where they are down the Pacific Rim, and was Heather the one who was bringing that up? I forget.
I believe so, yeah.
But it was something other than subduction of tectonic plates. But I forget exactly what the mechanism was.
The more I have investigated geology, the more I've come to the conclusion that it's the amount of evidence for what they say is going on is so scant, and they don't have the ability to see underground. So a lot of times they have the ability to just make up something, make a story up. And
who's there to challenge them?
Well, who's going to challenge them? Exactly.
A nice example here is, and I think it falls in line with the double layers, Neil. Maybe DJ can look that one up.
Sure.
It's an abbreviation of the MOHO layer. So it's like approximately 30 kilometers or miles down underneath our feet, and it's underneath. It's everywhere, and it's up to 500 meters thick layer, and basically that's where the magma resides, if you will. And so that's an interesting phenomena, and that's being explained, of course, in a certain way. But if you look at it, it's like a double layer underneath our feet, and creating the magma there, and all kinds of other processes in the.
I would think that our negative charge of the Earth's surface lies approximately 15 or so kilometers down.
Moho layer, DJ. Moho.
What was it? Moho?
MOHO.
But beyond that, you're right. There should be some sort of activity. So, Yeah,
Well,
the
no,
other way around.
no,
No,
and,
but my
M-O-H-O.
keyboard types backwards sometimes. This is
well, in California, along what
Yeah.
they call the San Andreas Fault, I think.
Yeah, something.
You can, I mean, there's evidence there that this western plate is sliding north because the kind of vegetation, the kind of soil matches up with vegetation and soil that's further south.
Oh, yes.
And you can, like, you drive along the Hetch Hetchy Reservoir, and you have one kind of landscape on the right and a totally different landscape on the left, you know. And then, of course, you get out to Point Reyes. So, I mean, there is, I don't know if I buy into everything they say about tectonic plates, but there are places where there's sliding going on between two plates.
Oh, certainly. That to me, and I'm not denying that at all. In fact, if given the pressure that must be being exerted if material is actually being created or whatever, it would be remiss of us to think that there isn't sliding going on where a plate is moving against another one. But we can also see, of course, them pulling apart over in the African Rift. So yes, clearly there's motion.
Mm-hmm.
In my opinion, it is much better explained with the expanding Earth model, and luckily, because of the nature of our work, unlike other talks of the electric Earth or the expanding Earth models, they have no mechanism where we're like sitting there going, what do we do with all this friggin' energy? You know, like there's so much going. Seeing the sun and the Earth and the solar system as a barely contained bound of energy ready to explode, like just with the wrong touch, two planets get too close together and we're blowing chunks off of each other. So it's a different way of looking at it, as opposed to the whole neutral, oh, nothing's going to happen until they actually collide, you know. Whereas we're like, no, it's going to get messy way before that.
Yeah. So, you know, I remember back in the spring you were discussing the model that you were proposing, at least. Could you expand on that at all? Did you go that direction with your presentation?
Yes, actually, it's one of the core things So I put forward a hypothesis, right? So I'm not saying this is correct or has to be or whatever, but the hypothesis was, could fusion be happening all around us? And and we are not seeing it. So we're missing a part of the picture here, piece of the puzzle. So when you think about that, that means the star fusion, of course, suddenly that comes into question. So the Big Bang and the supernovas and exploding white dwarfs and colliding neutron stars, they are supposedly the creators of the elements. But if it's an ongoing process on stars everywhere and even on planets, because as far as I could see, based on the spectroscopy data, is that stars mainly have hydrogen. Now I understand that there might be a whole metal core there, but if you go with that, where do all the heavy elements come from that are predominantly on planets? Right, so I believe that fusion is much more common than thought of. It's happening everywhere, and I suspect that this MOHO layer, this discontinuity, that is where the energetic fireworks happens in the electric circuitry on Earth, that Neil can explain much better than I can. And that is how fusion might be triggered, actually, deep down there. Now, what happens there probably is, when you look at the Mid-Oceanic Ridge, for example. The Mid-Oceanic Ridge is where it's basically a long volcano. And every volcano, which has, the Earth has about 1 million of them estimated conservatively underneath the oceans. So it's very much associated with water. We cannot escape that observation, right? There are only 1,500 or so on land, and then even near water. So water and volcanoes are combined. So water and magma have a relationship, I believe. Now, how can that be? How can that be? If you see that there is a hydrothermic circle or circulation going on in the ocean beds, and it comes up again, and it's taking up so-called dissolved metals and whatnot. But there's always an abundance of sulfur. There's way, way, way too much sulfur with volcanic activity. Why is there always so much sulfur? I believe the water with the oxygen in it, and this is the hypothesis, if you will, and it's sort of my belief, that the oxygen in the water is fused or used in fusion processes, creating an abundance of heat, for example, cold fusion processes, to be more precise. And if you have cold fusion processes going on there that turn the water into rocky material, so the oxygen into metals, then you have an explanation suddenly for a growth pattern that's kind of sort of like an ocean on Earth with a mid-oceanic ridge where the activity keeps happening. There are two circulations going on either side, and slowly material is being created there, pushing up and sideways with new material. That would cause a big zipper like that on the Earth. So I suspect fusion processes happening there, at least on that level.
It's condensate. I mean, would you argue condensation of this with the circuit? This is the one that was singing for me when you were talking about it. It has to do with the circuit between the Earth and the Sun.
How do you mean between the surface of the Sun?
Between the circuit between the Earth and the Sun.
Well, there's a current, not a circuit. Well, there are no circuits in space.
No, yeah,
okay.
Well,
this is another declarative statement that I'm going to.
Actually, I was going to say I'll argue with that.
I mean,
electricity has a traveling circuit.
Like, I have to say, as far as like openings of like cans of worms, hard declarative statements will from me will meet like plasma discharges.
Right.
We're still going to make them and still going to argue with
but it's like there are no
sorry, Richard.
It's like this is a hard statement, and it's like
the reason we even talk about circuits is because the way we create electricity is by creating a positive and negative pole in the right next to each other, either in a generator or a battery. Okay. And so then to get any work done, we have to make a wire that goes off in the distance and does things to various loads, and then comes back to that right next to where it started from.
Right.
And so we control the flow of the current by wires, and we keep the voltage and we keep the voltage low enough so it doesn't jump between the original points.
Okay.
But in space, you've got current flowing from a more positive place to a more negative place. It doesn't flow back. I mean, if the way the universe worked is you had a positive and negative pole next to each other, then they would arc right across. They wouldn't go anywhere.
This is arguing that. Okay, all right. Once again, a model you're arguing. Because,
well, regardless,
but it gets deep. It's a big rabbit hole there, and I don't want to
right.
that.
But if we can leave that just for a moment, the Earth, it has some kind of what we call a circuitry normally. It's a huge inductive homopolar generator. Neil, help me out.
That is correct. It is a homopolar generator.
So we have a huge potential difference, right, in the ionosphere. Help me out. How many kilovolts again?
300,000 to 500,000.
Something like 250,000 or more, yeah.
Depends on your layer where you go to. Yeah.
So then we have this insulating little layer, the atmosphere and the crust, if you will. And does that not induce, any disturbance in that huge thing going on, Neil, and you can explain this much better, but it would cause inductive things deep down underneath the Earth, right?
Oh, God, yes. Anything that is happening above the surface with all the atmosphere and everything above should also be occurring below, generally speaking.
So now we have a layer about 30 kilometers down underneath our feet, everywhere on Earth, where this relatively thin layer is between 100 and 500 meters thick, as far as I can remember from the top of my mind. And there are strange things happening there. And that's kind of sort of where the magma comes from. Now, everybody thinks, but you can find the evidence that it's not true, that the magma comes from the mantle. The heat comes up from the mantle and it goes to the crust and blah, 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 blah. That little layer, that discontinuity, that's still unexplained then through the normal convection model. But the magma we witness never ever comes from the mantle. It's always crust material, right? So I see a double layer effect, or at least an induction effect going on here, and in an electric universe concept paradigm.
Well, I would agree. So, yeah, in fact, I think it's rough. In fact, to expand on that, I would say that the reason that they're probably connected, then the oceans and the mantle, or this whole ring of fire and all the volcanoes, is because of the need to conduct all this electricity that is basically going through this planet, but it's not going to go hit this whole layer, the Earth we call the ground, all this dirt everywhere, silicates. It might have metal parts to it and other things like that, but it's just the most resistive crap. Okay, like, I mean,
exactly.
Electrically speaking, it is not what we want to put electricity through. We made wires for this reason. It's much easier to work with that. But in this case, the electricity still has to go. Where is it going to go? It's going to go through all of this salt water here. But there's going to be layers where it's going to be slightly more insulative. So it's probably going to, like I said, run around the sides. It's also going to want to go across the bottom of the floor of it too. That's basalt down there, a lot of it. So, and it's going to try to find its way into these, and of course these cracks could be where it's going in at. There's so many different ways to try to look at this now that we understand what the Earth is generally electric. Now, just like we were talking about the heliopause and the wondrous, the amount of energy they're seeing there now, just with, we're seeing H+ ions here, and we're seeing electrons, and they're seeing this all around, and they're going, where's this energy coming from? But they note that it's diffuse. Well, it's diffuse because it is the same energy that the surface of the sun has, except it's literally out there around the heliopause. It's relatively the same amount of energy, but that's such a big circle, that big area. Well, now that we're on a planet and we go inwards, now that we go further in, we have a higher and higher concentration of energy work. And it's going to happen, as you had seen there, in layers. There's going to be a relatively neutral point between two charged polarities. So I would think then the mantle would be one, and it has a certain charge, and that area in between that you've noted is an active layer where it is we're sort of floating on that in a way, that layer of whatever that molten stuff is because of this.
That is pretty much known, or at least very heavily speculated on, that it is almost like a greasy layer, like a magma layer or a liquid ocean, whatever. Yeah. And highly pressurized. But.
And of course, this is probably not helping that we have tons of pure water underneath the Earth. There must be, like, we've dug down and we've realized that this water will continue to seep in. So this must mean there is. I mean, look how much water is on this friggin' body. So where is this coming from?
That's the whole point. Now that's the key point you just made there, Neil. From my perspective, that's that double layer there that has basically highly pressurized magma with electric currents and induction stuff going on there. Again, you can explain that much better than I do. Water seeps in. The oxygen coming there can actually fuse. I believe a lot of oxygen, 2 oxygens, makes exactly 1 sulfur in a number of nucleons. So an oxygen has a standard number of 16, right? 2 times 16 is 32, which is exactly sulfur. And we see a huge amount of sulfur coming from these veins and volcanoes. Every time where there is water, there are volcanoes. And when there are volcanoes, there is sulfur. And if you loop the thing, the oxygen is turned into sulfur. And it can also create anomalous extra heat there, again, creating magma. And then, of course, the stuff has to, escape, and there's too much pressure, and there's whatever going on. And that is, I believe, the beginning of the whole geology on Earth, creating the continents, creating the oceans.
Well, so that would, okay, so you're basically saying water turns into material. And then if you want to have an expanding Earth, then it sounds like it would need to be based on the Earth always getting new water from outside.
So look at a tree.
The fact you have a net inflow of water and water gets converted to material, then that's how you could have an expanding Earth.
Yes, because if we look at a tree, where does the growth of a tree take place? Not in the core, not way, way on the outside. No, just below the surface. So a couple of millimeters or half a centimeter, whatever, below the surface, right? If you look at our skin, same thing. Human body. That's where the growth of the skin takes place. So what we're witnessing in those terms of an expanding Earth theory, I believe we're witnessing the growth of the skin being pushed aside, right? Creating the tectonic plate theory, if you will.
Right,
okay.
But in the case of the body, the material is coming from the food you eat.
Yes, and in this case,
there's got to be a net inflow of some kind of material.
In that case, you have an Earth with an abundance of water coming in, or at least it has it from a starting point. Now, I believe it will come in constantly. I don't know, but if you look at geology processes on a planetary bodies, it is interesting to note that the only planetary bodies with a geology just like Earth, with volcanism, etc., just like Earth, usually have water or are in a place where there is huge induction going on with a big body like Jupiter, a small moon being mangled, basically. But, I mean,
Io and sulfur come to mind.
And sulfur, again. So the point, and Mars is dried up, and it has a metallic reddish surface, so it's all turned into metals. The water is gone, it's used up. But the point is, the water is what is actually responsible for creating geology, including what we observe as what looks like an expanding Earth. And yes, it's sort of an expanding Earth, but I don't think that much. That's all.
What's going on here? Do you see this? This is to the south of
that looks like an island.
Look at this thing. It's really fast, right in the step.
Looks like a typhoon.
So that's right now.
We should warn them.
Wow. That's pretty amazing. As far as a concentrated, vortex, that's one of the most intense ones I've seen.
Well, we have to look at those now as basically the ionosphere is discharging to the ocean, basically.
Yes.
And we should see those underneath the Earth.
Now you also have what many people point out. Suddenly you have a correlation between weather patterns and volcanism and earthquakes. How come they coincide? Well, because the common thing here is this electric induction going on. These currents are moving and changing and shifting and pressuring and whatnot. Creating weather patterns, creating extra activity in that MOHO layer, whatever,
Oh, I see counter rotation.
Look, and they can't it's so fast here, they can't, there's, you can see the...
Is that Hawaii?
This is off the coast of Hawaii, it would be one thing if it was here, but it's here. So.
Yeah, you may not want to be, you don't want that thing on land, maybe.
Oh, I see. So that's going to be the next island.
This is live.
No, it is. That's how Hawaiian develops. See, each of those islands used to be the volcano.
You think? Yeah. To me, that's a fairly big. That's a ring. You see? Does it see how significant that is?
And there's the other ones over to the left too.
Yeah. But I mean, these are a little bit more dispersed. You can take a look at them.
So are these each volcanoes?
No, this is just weather patterns.
And what's the red mean?
Speed.
Oh. Okay. Oh, so it's, yeah, you can see the vortex. You can sort of fall into the vortex.
Yeah, absolutely.
Whoa, there I go.
There's two Birkeland currents there.
Here's counter rotation. But this is this concept of it's the breaking of the equilibrium between them, and here's the counter rotation.
Looks quite calm there in that other spot, just between them there.
That's pretty good.
It's like the guy in the boat sitting there, everyone else is screaming around him. He's like, no, I don't see anything. It's beautiful here.
Right. This is, the whole Japan thing, right? What's been going on.
So if you're in a sailboat, you want to have access to internet, Go where the fast winds are.
If these are electrical in nature, it's odd. They should actually be pulled towards, like when they start sensing like volcanoes off to one side, they should go there. Like they should feel that they should sort of there would be a tug because they would induce current through that lava, so to speak, that's conductive, and it will go through into the earth. But they would be attracted to them. It's sort of like putting lag on one side. It's sort of pulling it to the left, or spinning momentum being absorbed by something draining it away. It would feel to the spinning electrons. It would feel like friction, but it's more induction. This is why there's a relationship between. That's why there's a relationship between resistance itself, which is kind of like friction, and induction, which is
right. But this is where you start seeing a continuum between the ideas of pressure and like all these modalities that we've separated and individuated. There's a continuum between them, ideas of pressure and sound, and then into our formal electromagnetic spectrum. And anyway, this is I'm seeing this pretty strongly these days.
However,
I think Jim could expand on that.
Yeah, that's an important point. That idea of pressure leading to charged double layers, or like that piezoelectric properties. We see that in all materials. And what's interesting, like in the mainstream, the problem we have is there's every field has its own jargon, so you don't see when they're talking about the same thing. For example, if you look at an astrophysicist, will talk about shock waves in interstellar clouds, leaving an ionization front where the electrons are driven out ahead of the protons. But what you're talking about is a pressure wave that leads to an electric field at some front. And then you might hear, and if you're a neurobiologist, you talk about how osmotic pressure creates this action potential, which propagates along, an axon. But once you see that you're talking about the same things, you see all these weird, like the sun travels along the surface of the local interstellar cloud, and what happens in a neuron is the action potential travels along the surface of a filamentary axon, and it's the same thing caused by the same thing, and it's always a pressure differential that causes that. And that's where I still get frustrated with Wall's. I hope he doesn't lead people astray with that whole his idea of dipole gravity, because what you really need to see is that gravity. He put it right back in his book, The Electric Universe. This is before he started the whole dipole gravity thing. He had, let me quote from this. If the sun is an electric discharge phenomena, then the photosphere is a luminous plasma sheath at some unknown height above the body of the sun. And if the sun is charged positively at depth by a gravitationally induced drift of electrons toward the surface, then electrical repulsion still, will prevent the collapse. But that was the right idea, is not that electricity is the cause of gravity, but in that case, gravity caused a radial charge segregation. And that's the same thing, though. All you need to make that be the same thing is you have to define gravity then as it's really a pressure, but then you need a medium outside, not a vacuum outside the sun. If you want to make gravity due to a pressure, you need a medium out there that can provide that pressure, and then we're back in that whole, you need some kind of ether out there, and that was the right way to go, though. But over and over.
This is where, I mean, I'm finding. Sorry to interject, but the idea of minimum energy configuration, which we like a lot. There's the expansion into motion, which we see, and this seems to be a spiral nature. And then there's the desire to go back to that equilibrium, and that seems to me to be gravity. It's back to that still lowest energy configuration. And as far as a generalization, I find that it's a nice model to start looking at as far as generalizing. I don't know if you would agree with that, Jim.
I'm just having trouble getting the what you said. Sorry about that.
Yeah, no. As far as your model, what you're talking about with gravity, right? This pull back into a central point, right? As far as electricity, if you link pressure as a continuum, the change in the observation of pressure variation, where there's rarefaction and compression, right? Those two, right? And they expand out if there's a disturbance from stillness, right? That expanding out has a rotational aspect to it, and then its desire to come back into equilibrium, lowest energy configuration, is a gravitational action.
Right. Well, gravity being a pressure to push things, basically push things together
to equilibrium. Anyway,
well, unless it has a correlation, a true correlation that is, and I'm not sure there, with the Z-pinch effect, right? Mm-hmm. Maybe it is a result of that, or a side effect.
Yeah, similar.
That's interesting. I never thought of that. My first instinct when I hear about the surface of bodies is to fall back onto basic known electrical things, and one of the things that pops up is like it's either Lenz's law or the skin effect, where if you have a vibrating current flowing through a metal body, generally speaking, like the sun or whatever, it's going to the most electrons, because they travel faster, will travel along the surface. Those protons will get shoved inwards or away from that surface in either direction. This is because of the nature of inductance. Basically, it's a lot easier to move these electrons around than it is to try to move these protons. So it will generally give every wire on the net outside negative, or any sphere immersed in a plasma the same thing.
Well, we're on gravity too.
Yes.
Ido, do you have anything to say about gravity?
Oh God, no! That's the most elusive thing. I'm not sure if I'm not sure if it's connected to the EM electromagnetism at all, because it's everywhere and it's always there. Now it might have something. Yeah.
I'm just going to jump in aggressively. What if you thought of your proton as something that was pulling in? It was seeking. It was a center seek of equilibrium, a point of equilibrium.
Well, you're putting me a little bit on the spot there, and this is just speculation, okay? But the simplest way, a simple way to look at this is a proton being a bubble in the ether. Now, I'm not going to ether, mind you. I have no clue what it is. I don't even want to go there. But it's a bubble in the ether. So it's displaced ether. It's a bubble. Why it's there, I don't know. But the displaced ether would be the electron. So the countercharge, if you will, wanting to go back to that equilibrium of taking care of that bubble, if you will. So that would explain why they're opposite in the same charge, for example. But it's just a simple way of looking at it. So that would be, but that would be more a primal cause for proton-electron duality and why they're similar, have the same charge but are opposite, if you will, and why they attract each other. I don't know why they don't annihilate each other then. So it's not a good model, but it's a way of looking at it.
I think your model explains a lot, actually. Well, in my head, but go on.
Yeah, but the structured atom model is more, it's explanatory for how the nucleus is structured. And you can learn a whole lot there, and it's very fundamental.
Yes.
But if you want to go a little bit further, it comes down to the question, what is a proton and what is what we call an electron, right?
And what if you go that whole major leap and say that the electron is the disturbance and the proton is the center?
I've kind of let go of that concept I just conveyed to you because I believe, live more in the electric universe indeed.
Well, I'm saying electric.
Yes. So if you go back to the viewer there, DJ, the yellow bar there on top.
Oh.
And yeah, click the second element, deuterium.
Oh, are you seeing my screen? I think someone else has grabbed the screen.
Oh, someone did it.
I got it.
Oh, yeah.
Thank you, Robert.
Robert's there.
Hey, savior there. So this is the most fundamental.
By the way, Robert, would you do that? Please let me know, because I was
Sorry.
I thought, why is DJ so attentive?
I was like, what's going on? Who are you talking about?
So
I was off on the process.
So this is deuterium. Why is deuterium so important? It's the first element, right, that we know of that has a stable so-called neutron in it, in the nucleus, right? A free neutron decays into a hydrogen, basically, a proton and an electron pair. So imagine between the two protons here, this is heavy water, if you will, the deuterium, hydrogen 2 hydrogen. Imagine the inner electron right smack in the middle of those two protons, right? The other electron is connected to the both outer poles, so the left and the right, if you will, in some kind of fashion. So that's where the outer electron is. So the outer electron has a path, if you will, or how do you call that? An orbit almost, right? An orbital. It doesn't really move around. And the inner electron is there without a path. That is, the path has 0 in length because the protons touch each other. But I'm inclined right now more to believe that an electron is a charge. It's just a charge, and it's a certain charge because it's connected to that fundamental thing, a proton.
What's that mean, a charge?
A charge. What we would like to call electricity, I guess.
Is it a potential?
I don't know.
By definition.
But this is a fundamental point, though, right? I mean, what is that? Just to be a little bit clinical, what is charge?
That's ultimately the question. I think
it's something you can measure with what?
Tesla posed this quite right. He said, when we and I know he had made many quotes, but he said something to the effect, the day that we understand what electricity is, basically everything is limitless, right? Then we're really there.
Right.
That's the question. I don't know.
That's the quest.
Well, if you look at it this way, at least, you can see how it interacts with matter in a primordial way. And why I point this out, because this is for me also not so much speculation, but trying to get there, right? Trying to find an answer, trying to go there. But it leads to this structural thing. Mm-hmm. So I just follow a reversed method, if you will, from the structure. I tried of the nucleus, we can go a level further. And now we can go to the next level. And we can at least try and look, okay, what is going on there? How does it interact? how does it relate to the elements? And finally, when we have some truth there, some causal correlations there, which I believe the SAM model shows, then we can go to the next level. What is a proton? What is an electron? I still have no clue. The furthest we can distill it is looking at a proton as the material thing, the matter, right? And the electron, yeah, what is it? We don't even know.
But they're actions, aren't they?
Yeah, well,
They're observed.
You can call it many things, I think.
Yeah.
If I was to be so bold, what I'm looking at is you have, I just thinking of them as two positively charged spheres, and then you have a negative force will automatically come between them because they are right there. If you know what I mean, like they're right beside each other. There will be a likes. They can only get so close, and then there will be something gluing them together. That's the nuclear. That's the electron between those. I mean, and it's not, or as you said, orbiting now with such a great distance, such freedom away from the nucleus, like a regular electron in the electron shell. No, it is now serving the purpose of glue, and it's sitting right there. And that change of mental image.
And that is there's a change. It's a fundamental change. Why we tend to call an inner and outer electron, or even a neutron, but I stepped away from that neutron thing completely. So a neutron really doesn't exist, right?
Exactly.
We're looking at this. And believe it or not, many people in the main physics are going this, accepting the duality, and that a neutron might not be a fundamental particle. So many are leading that way.
That's good.
It's interesting because that message, just the fact that you've been, just such a major advocate of that message, that it rings out and people start resonating with it.
No, this was
really
for me totally mind blowing. For example, at the Cold Fusion conference, I anticipated quite a bit of resistance here, especially on that point. So I had a nice little handout talking about the new neutron, basically this concept here, right? Mm-hmm. And I gave it to people, and there were MIT professors there, professor of such and such in Marseille, France, or in Japan, or whatever. Many Americans, of course, it was in the States. And so I anticipated quite hostile reactions, or at least, shoulder lifting, kind of like, what are you talking about? You know nothing. Instead, the reactions were, oh, no, there's actually quite a bit of evidence for that, yada, 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 in quantum mechanics terms.
Right.
So my mind,
like
my mouth fell open.
Yeah, you reach that threshold of courage to go over it, and then because of that, all of a sudden it's listenable.
And not only that,
it feels like it.
Well, to my utter amazement, there are many people in physics that are leaning in this direction. Mm-hmm. So that's utterly mind blowing. But it is
versus because we've been we've been complicated out of our yin yang.
Oh God, it's way too much already. That's one of the things I'm trying to do to make it more simple.
Right.
But the change that Neil was just alluding to, there's a change of state, if you will, that makes them come together and kind of click permanently. There's a whole thing going on there. We're looking at this way too simplistic still. That's what I'm saying. There's a whole bunch of dynamics going on.
Oh,
so
God.
So imagine it just be one electric current loop here, right? It goes from the left proton to the right proton, and then it exits the proton on the right side and goes all the way around to the left side, if you will. But somehow it makes one electric current. Now, believe it or not, this is the most fundamental building block of the nucleus in this model. But every nucleus that is there and makes basically one loop. So what is the nucleus of an atom? It's kind of like a chain of beads around your neck tied into a ball. And it's still one bead. It's still one chain. It's still one chain of beads, right? So it's like one wire, if you will, tied into a knot. When there are too many exits and openings, it's chemically active. When it's completely tied into itself, and there's a term there that I forgot, a specific term for a knot, then it's tied into itself. It's noble gas, or a molecule like a CO2. right? No more reactivity. It became one loop.
Valence or something.
Yeah, well, it's the valence, is the chemical reactivity, if you will. So when that disappears after a chemical reaction, so a molecule, not an atom, a molecule, so like a CO2 or a noble gas, both have the loop completed. And so I see it as a
I'm
charm.
trying to see what like Buddy's talking about here when he talks about the Doherty set, and he's always talking about that helical force around here. That it like fits right in between here. If you ever see his drawings, a particular one, I can't remember. I have to pull it up.
He has very interesting drawings, and I think he picks up on something primordial in patterns, and I think it comes from this stuff, because this is as primordial as I can get, at least.
Right.
Well,
why are you starting with deuterium instead of just one?
Sorry?
Why, like with deuterium, you would bring up deuterium here.
Oh, well, hydrogen has no neutrons. A neutron is not stable. And the first element that has the so-called neutron, which I explain as being an inner electron. So the deuterium is the first element with a neutron, meaning an inner electron. So a connection between two protons. That's why it's the first.
There's a part of me that is, when I see this, I can envision, just because of as you go down the list, the ability for this to be polarized. For example, if I had a positive plate above and a negative plate below, then the middle neutron or the middle electron will be slightly pulled up towards that plate, and the two positives will be slightly pulled down. It wouldn't exactly look like Mickey Mouse ears in the water, hydrogen, oxygen type thing, but it would still have that slight angle. This is the part that is making me question, because obviously with the hydrogen, it is the lightest element we have, but is it really so light as to, like, where would it get its response to gravity? Does it even have any?
Yes, because it has the outer electron orbit, and the outer electron orbit, when it's there, it's like a path with a dimension. The inner electron basically has no dimension there, so it would be, it wouldn't be interacting with the field, if you will. But if you implement here two plates with a different potential, so positive and negative, if you will,
yeah,
right, and let's say the positive has a lack of electrons, right?
Mm-hmm.
Then would not your outer electron be attracted or try to make a connection to that positive plate on top?
Of course, but that's called electrostatics. And that is actually something we can shield against on that, but you can't do it if it's inside the nucleus, which is what we're talking about. What is gravity? Trying to understand the nature there. That's all.
Right. So this is important what we're doing here.
Yes.
So through this reasoning, we can see that gravity might actually be a nuclear function of the nucleus.
And the amount of electrons and neutrons that it has within it, or electrons and...
Yes. The electrons in the nucleus are the old-fashioned neutrons.
And obviously, as you build a larger body of protons with these neutrons in them, you're going to have more electrons and more protons glued together. But they're going to have the potential then, if they're in this situation with a plate on top and a plate on bottom, some are going to be pulled some way and some are going to be pulled another, and there's going to be a slight, it's going to be slightly misshapen. Not really, but slightly. And that slight misshapenness could be this dipole effect we're talking about. This is the nature of gravity that I find fascinating. I'm really, obviously, completely throwing away everything that Einstein ever said on this, because as much as I love your formulas, we have to actually know and why this can't be shielded. But why does it exactly conform to the Coulomb's law otherwise? It's such a link. And
right. So here you see, it's not in the right direction. We've been experimenting a little bit. Sorry about that. But here you see inner electrons represented by the yellow ball, if you will, right?
Right.
Now, don't think this is correct. It's wrong. Doesn't matter. Where they are not, if you will, is where the outer electron is connected, making that pathway to another point on the nucleus. That's your orbital,
Right.
right? And this here is in the deuterium. So here you see the deuterium again. And now
Could you
with
go
the
back
electron,
to the
the inner
carbon
electron.
where you were moments ago?
It was carbon 12.
Was it carbon 12?
Yeah.
The reason I wanted to point that out, I noticed that in 2 points you don't have a link at the top and bottom. That there is no electron holding those three in the middle on the top and bottom of this.
Yeah, well, this is a wrong configuration. We've been playing with that.
Okay, fair enough.
I think
you got an icosahedron, though, right?
Yeah, but Robert has a little bit more.
The orbitals are the electrons are a little bit wanky.
Well, the orbitals would be coming, as I pointed out, with the deuterium on both sides.
They're way outside. They're way away from here.
Okay.
Yeah, so they come out on both sides of that pair, right? There are 6 pairs there. 6 pairs of 2 protons with an electron in between. So the outside, the tips on the outside of that inner electron, that's where the outer electron connects, making a nice, if you equate it, like that sun loop that we saw with the sun eruption, that nice loop there. Think of it, that's how I think of an outer electron, like a solar flare loop that we saw at the beginning of the talk here.
Well, it kind of makes sense because they're going to open up a little bit on both ends because the positives won't want to get so close together. So they're going to want to spread out a bit. This is basically electrostatics. When you were talking, Ido, you mentioned the flow. And although I can understand that some people really, really like this, but I don't know obviously there has to be some motion. I'm not denying that. I mean, clearly there's more going on than what we're seeing. So I'm with you. But there is a nature to that a lot of this is simply electrostatics, really. We're just basically looking at charges and point charges and trying to understand them because they will definitely sit there balanced. We've seen this with magnets, for example, where they will just come close and not touch, so that we know that these type of effects can exist and that they have their own polarities. And of course, there will be some sort of magnetism in there, but I'm not really sure if there is flow. I just know that when you mentioned something like this, and I see that they should be slightly opened up in each end. And then you mentioned just a second ago that there will be an electron will be attached to that or attracted to, but cannot get any closer, which is now on the shell electron, and it will sit on those 2 points. That's where it should sit. Like I love the way that you put this together. It's like that's where it should sit because now it is. Go on, sorry.
Yeah, well, this is most interesting, and I'm trying to get there together with James, but we can do only so much because we have to do a lot of other things. This is not so much complaining, but I would like to go there with the modeling software so I can show this much easier. Not only that, the work I've been doing with this is from what I could do, and I can't show it right here, right now, is it does correlate to what we see is the orbital structure of the elements, right? So the p orbitals, the s orbitals, the d orbitals, and they have a certain shape, more or less.
Right.
Now, if I can find that connection to be true with this as well, I mean, then we're really talking, right? Then we can add to the list of what Sam is being able to do. Then we can add to the list that the orbital structure, as we know it from our experiments, is actually shown or comes from the structured atom model. That is a truth. But there's so much work to do.
You don't show the orbital electrons at all in your image here.
Nope.
Have you done any work at visualizing the outer electrons and how they're connected?
That's where we want to go. I would like to do it today, if you will, but
just as far as because it's been 3.5-4 years now that I've dove into the development environment. And more highly recommend exploring Unity. And if you're interested in looking at it as far as a visualization tool, and I know that James would be into it. It's like I'd be more than willing to like introduce you to what it offers as far as a visualization tool and the ability to create a pipeline of visualization. Because you're right on it. But I would definitely. I think you're up for it too because I know your exposure because we've known each other for a long time. But I see the direction and the platform that he's using. I don't think it would be a big jump for him to move to it. It's always once again there's a threshold that I'm not familiar with. I'm not going to do it because I don't know enough about it. But what's going on with that platform is mind-boggling, and it offers a lot. So I'm just putting it out on the table.
No, it's good that you mention it, and I'll definitely pass it on because this is definitely James's spiel, right? I'm not so good at that.
But once again, the active doing and putting it together, because you model, you're doing it, but it's a tool that with just a little bit of introduction, you could be off to the races pretty quickly, and it's a very and by the way, from out of the team, which is really really huge now. There's thousands, but it started out of the Netherlands and Denmark. So.
Right.
I just want to do that because I'm such a fan of James and Ito's work. I just wanted to, since they gave me access to do that, he was talking about it. I could just handle the script and put it out there.
Sure. Yeah, but I'm saying that there's a next level that it's going, and anyway, that's my input.
So, what can we do with this knowledge to understand the sun, right? I haven't heard Jim enough. I know this is Jim's favorite topic, and he made a whole list of questions, and I'm sure we touched on maybe one or two of them. So.
Yeah,
right?
I forget what the questions even are now.
Well, you had.
We're just discussing. We decided that we were going to discuss the sun a bit today.
I never saw the questions.
There was never any questions. It was just kind of. It was more. I'm going to grab the screen back, Robert. Yeah.
Did everyone get a chance to see Don Scott's video? That what was it? 43 minutes to 44, where he's showing the sunspot.
Right.
That one, there's like so much information in there. If you watch what's really going on, where things disappear, and you can even see when he did that, I think that was before he got into the counter rotation stuff enough, because you can see counter rotation in the toroidal portion of that. You can see basically, you can see counter rotation in the toroid around the sunspot.
This whole because this was an ongoing debate that you had, right, with this toroidal nature. Could you expand on what your just exploration of that has been?
Well, I mean, the biggest thing, and this is shown wrong in the even in some of the early EU material, they didn't know why a pinch should happen where it does. And you get they show images of, current flowing along, or maybe a pair of current filaments, and then for no apparent reason, they just do this nice tight little pinch, and then it goes on. And that's like total opposite, though, of what we know about Bessel-Gaussian filaments. Is what they should do is they should stay extremely coherent and even repair themselves after they've been, after there's an obstruction or something. So, in other words, a current shouldn't just wig out like that for no apparent reason somewhere along its length. Now, what I found on the astronomical scale was easiest to see is everywhere we see a pinch and a toroidal formation, it's where a current crosses through a double layer. And that's the key part that's everyone, I think, is still missing. Like even a lot of people in the bigger names in the EU community, is that what you have to accept in the beginning, to get a Birkeland current to flow, you have to have an electric field, right? But the two oppositely charged areas, if you want, are already going to be separated by charged double layers. You always have, whether you see them or not, they're going to be out there. And that's what you see, for example, in the thing with the local chimney. That's where I first stumbled on that weird idea that right where this hourglass shape chimney pinches, it happens right where this current flow goes through the galactic plane, and then you have a torus centered right at the galactic plane. So what it would tell me in the lab is, just because you see this pinch and you think it just happens somewhere, what you don't necessarily see in the lab is that there are already charged double layers before there's even electric discharge. But this is everywhere. Like even in if you want to explain a hurricane, kind of like, you notice a hurricane is shaped kind of like a galaxy. But in the case of a hurricane, it doesn't just happen if there's a discharge from space to the Earth. A hurricane doesn't just happen at any altitude. That cloud layer, or that double layer, is already there before that current flows through it, and that's what determines the height of a hurricane above the Earth. It happens in the atmosphere, and with a galaxy, I would suspect, since we get the same kind of shape, even as like a hurricane, that what we're not seeing is that a galaxy doesn't just form anywhere in space along this. There must be huge double layers where this current is flowing through that, and that's where you get a galaxy. It's the same type of shape.
Right.
But that's the part that's missing, is you don't think, like we talk about current filaments in space, over and over there's a focus on that. But, and we know that, like Walt will tell you that objects in space tend to be, if they're charged differently, they're protected by charge. They insulate themselves by these charged double layers. But that means even on huge scales, we should expect to see charged double layers. Or what I'm saying is, we're not seeing these large double layers until we get like galaxy formation where a current flows through them. But at any rate, there's no reason that we should just get a pinch and a torus. What I'll suggest is, when we see a torus, that the material in the torus is being formed out of the material of the double layer itself. And again, that's easier to see in the local chimney, where you have this hourglass-shaped pinch, and then there's that torus. But in that case, you can see like almost missing material in the galactic plane and extra material in the torus. So basically, I think there'd be a lot of work to be done on looking at what happens with we have a model for a Bessel function current, but it would be fun to model what happens when one of those flows through charged double layers. We have good models of what a charged double layer should look like. But what happens when a Birkeland current flows through a charged double layer? And I suspect that all these answers about like toroidal formation and toroidal rotation can be explained by that.
Well, that's an interesting model. I had a much simpler one. I mean, if we're throwing out models of why do stars form, Z pinches form in a certain place. I was using a really simple metaphor of, like, you have a stream of water, right? And you, if you have a little pebble, then maybe the stream pushes it along, right? But when it comes to a big rock, it goes around it. So I was thinking that you get a Z pinch because you came to a bunch of material that it was cheaper to go around it than to try to carry it along with the current. I mean, that's a totally different take on it, but it was the simple one I was using so far.
It has the same general idea in that you're at least including what's happening outside of the filament itself. Like, in most of the EU diagrams of Z pinches, they don't talk about any change in the background. It's like it's flowing along some magnetic and electric field, and they assume that the medium along the whole length is pretty much the same. And that's what I'm saying can't be right. There has to be something going on at that point. And again, from that...
Sorry,
go ahead.
Jim. I just wanted to say that this is... I was arguing with you on this subject long ago when I said there's an electric field around the sun, and the the current will come into the field first. That's the first thing it encounters. It is all it sees. It only sees this electric field around the sun as what it is. To it, all the planets and everything are just interspersed charge inside of that. It comes down to the surface of this bubble, the heliopause, so to speak, and it's going to interact with that first, and then the energy is going to pass through that double layer and then continue on to the sun. I see the same thing with the galaxies, that they're going to pinch down, and they do this, of course. The reason the pinches start is because there's a magnetic field there, and it's going to draw, of course, the metal of the sun is going to focus that right in, but it also has an electric field that pushes out from it. That's a perfect example of what we're looking at right there. And it has a bubble around it, and that electric field is where, all the planets and everything are inside of that. And so that's how it's going to interact with this this thing. This is why I was wondering, how did the rings affect, does Jupiter steal parts of it directly, or is it going to steal from this energy that has passed through the double layer? Now, clearly, in my opinion, it's doing it that way. But obviously the sun's getting the brunt of it, and of course, as we know, there's currents traveling both inwards, but there's also currents both traveling outwards, because there's induced currents on the electric field as well, on the Birkeland current as well, on each of the individual sheaths on the outside. So you're going to have charge flow in two directions, although one is more dominant than the other, and which gives us our own polarity. All of this stuff sort of works together in my mind. But obviously, by talking to people like yourself, who have shown me, it only reinforces that what we're seeing is clearly electrical, and that there is much more going on. When I see, for example, the pinch along the Butterfly Nebula, there's just like that. When I see something like that, I see this. This is the magnetic part in the middle, is where material will begin to aggregate, will begin to form, and it is pulled in by Markov convection to the tube itself, but pulled right in to the center. And this is, of course, probably what's making stars and planets and so forth. Once that happens, it has its own field, and it has a load. It's now a load on the circuit. Because of that extra inductance, it's not necessary. Some of it will be turned into heat, obviously, transformed, some into light, obviously, but a vast majority of these charges will continue to flow because they are induced. Induction does not turn the energy into something else, but to electric current, it is like a resistance, it's an impedance to flow. So, and of course that makes sense because there's now heat being generated, light being generated, and so on. There's a load being expressed along the circuit. This is what I'm seeing anyway. And argue with me though if you disagree. So.